The scientific method is the process of developing models of the world and testing those models with data. A model is a simplified description of the world, and for most economics, it is interchangeable with theory. Here's an example. Employers have an incentive to pay highly productive employees more money, and one of the ways in which people become more productive is by obtaining an education. As such, I expect many people to pursue educations, as I expect those with higher educations will earn higher wages once they graduate. Like other sciences, economics is mathematically rigorous. It isn't enough to just make claims off the cuff or by appealing to anecdotes. The crazy math you see here represents a consumer optimizing their consumption choices, and if you've taken multivariate calculus, you may be able to make sense of it. Don't worry if you haven't, though. The good news is that what we derive here can be expressed graphically much more intuitively. On the graph is the rather innocuous conclusion that if I increase a person's income, the theory predicts they will buy more of the good in question. Einstein called math the poetry of logical ideas, and he's right. Math is the greatest tool humans have ever discovered, and it alone has the power to unlock the secrets of the universe. It is my hope that this course will encourage you to take more math classes. Trust me, it will be well worth it. But for now, we can rest on the more intuitive mathematics of graphs. Graphs show the relationship between two variables within a given function. Here we have two unseen functions graphed, one for supply and one for demand. We can see that the relationship between our two chosen variables, price and quantity, are opposite for each function. For demand, when I lower prices, the quantity demanded rises. For supply, when I lower prices, the quantity supplied falls. Remember, graphs are just a combination of two number lines. As we move rightward from any point on the graph, we are increasing the value for quantity. As we move upward from any point on the graph, we are increasing the value for price. Graphs are another way of displaying our economic models, and they also let us pair the theory with real-world data. We can use real-world data to test my economic model, which suggests that more education leads to higher wages. This is data for 526 people and shows the relationship between their hourly wage and the years of education they got. It's a little old, from 1976, but I would expect the theory to apply then too. For some reasons I won't bother you with, our best test of the theory is to see if years of education corresponds to the natural logarithm of wages. And statistical methods allow us to estimate the exact relationship observed in our sample of 526 people. On the right, we can see an equation which says that for each year of education you get, your wages end up being about 8.3% higher. That would imply that going to 4 years of college would mean you will make around 37% more money per hour than if you did not go to college. Sounds pretty good. Testing our theories like this is important. If people who got more education made less money, we would need to abandon our theory and rethink our assumptions about the world. But as we will see, the scientific method demands a lot more than just checking to see if your predictions match reality. Even though we see that 4 years of college corresponded to 37% higher wages, it does not necessarily follow that if I sent a bunch of people to college who would not have otherwise gone, that they would see this benefit on average, let alone individually. To see why, we need to talk about correlation and causation, which is the next video.